All right, so we start chapter 11. Chapter 11 is surface area and volume. It's all 3D shapes and that sort of thing. If you have time, go back into your book and read over section 11.1. It has a lot of vocab in it and some drawing things and whatnot, but it would be good information to have. It's not necessary, but it would be very helpful to have. So if you have time, go back and look at that. So let's get started. We're going to do all the surface areas today. So, some definitions. We have a prism. So, think of those things that show pretty rainbows all over the walls. It's a polyhedron with exactly two congruent parallel faces. Let me throw a new vocab word at you. A polyhedron just means that all of the faces are polygons. So, a soccer ball is a polyhedron. A rectangular box is a polyhedron. Anything that has polygons on all sides is called a prism. It has two congruent parallel faces. The parallel faces of a prism are called the bases, and this is actually how they get their name. So if you have a prism that has hexagons on both ends, it's a hexagonal prism because it has hexagons on the ends of it. If it has triangles on the ends of it, it's a triangular prism. So we name everything by the bases. If it's a box, it's a rectangular prism or a square prism, depending on what we have. The lateral faces are the non-parallel faces of a prism. So that would be the ones, like on this box, would be the ones around the outside. You have to, with a rectangular prism, it's a little bit tougher because we don't know which ones are actually the bases because everything's parallel. But if you have a hexagonal prism, then the lateral faces are all the rectangles around the outside of the prism, and then the two hexagons are the bases. Then you guys know what altitudes are. An altitude is a perpendicular segment that joins the planes of the bases, and the altitude is related to the height. The height is the length of an altitude. So that's how we tell the height. When we get to volume, that's going to be really important. There's two types of prisms. You can have right prisms and oblique prisms. A right prism is just what we're used to. They're straight up and down, they're not slanted, they're not anything. And if you wanted to find the altitude, you would just find one of the edges, one of the lateral edges right here, and that would be your altitude. But an oblique prism is different. It's slanted. It's like a stack of paper that you just shove over so everything's slanted. So the altitude is a perpendicular out here, kind of like an obtuse triangle. So then we would have to know what that is in order to find the height. For surface area, there are two parts. Surface area is always the lateral area plus the area of the two bases, depending on what they are. The lateral area is the sum of the areas of all the lateral faces. So think rectangles. All of the rectangles around the outside of the shape. And then the surface area, you take whatever the lateral area is and you add the two bases to it. So if we had a hexagonal prism, we would add up all the rectangles and then add the areas of the two hexagons as well. There's another way you can do this as well. We just did a lab on this where you can use a net to find the surface area of the prism. So what you do is if you were to cut on a couple of edges and open the shape up to where it lays flat, like this shape here, if we folded this all up, it would make a box. It would make a rectangular prism. So in order to find the surface area of the prism, surface area being area of the surfaces, area of all surfaces, then you would just go through and find the area of each surface and add them all together, and that would give you the surface area. It's like covering something with a piece of wrapping paper. You just need to know how much wrapping paper to do. So like this section right here, its area is 12. This section's 20. This section's 12. This section's 15. This section's 20. That section's 15. All of those areas, we use a formula from chapter 10 for area of a rectangle. So then to find the surface area, we'd add all these things up. So we'll do 15 plus 15 is 30, plus 20 is 50, plus 20 is 70, plus 24 would be 94. And it would be units squared if we knew what the units were, because it is still area. Triangular prism. So remember we said it's lateral area plus 2 area, the bases. So the lateral area is all the rectangles around the outside. Well, I've got one rectangle here on the front that's 5 by 12. So that would be 60. The rectangle on the back side is the same as the front side, so that one's also 60. And then there's a rectangle on the bottom that's 6 by 12, so that one's 72. Plus 2 of the triangles. And so we need to find what the triangles are. This particular triangle is isosceles. We don't have the height. The height would be right here. We don't have that. We don't have angles, so we can't use 30, 60, 90. But when you draw the height like that, it splits that 6 in half. It makes this 3 and 3. That's a Pythagorean theorem situation. So we can do 3 squared plus h squared equals 5 squared. And we can solve that out. So 5 squared is 25. 3 squared is 9. I'm going to subtract 9 from both sides and get 16. And then we've got h squared equals 16. So then the height is 4. And if you remember how to find area of a triangle, it's 1/2 base times height. So 1/2 times 24 would be 12. So in this formula we put 12. So this is the front side plus the back side plus the base plus 2 of the triangles on the end. And you're going to add this all together. So 120 plus 72 plus 24, we get 216. And it's centimeters squared. Okay? Surface area is the area of all the surfaces. Alright, same deal. So, area of all the rectangles around the outside. We have a missing piece though, right here. Because I don't have that, I need that for the front side of the shape. So, if you do Pythagorean theorem, again, because it's a right triangle, 3 squared plus 4 squared equals c squared. And you do your math, you'll get c equals 5. So this side is 5. We'll use it for whatever we need to do. So the rectangle in the front is 5 by 6. It's 30. The rectangle on the left back side is 3 across and 6 high, so that's 18. The rectangle on the right back is 4 by 6, so that's 24. Now we need to add 2 of the triangles. Triangles are 1/2 base times height. 1/2 times the base times the height. So we get 1/2 times 3 times 4 is 6. Now we just need to add everything together. So 30 plus 18 plus 24 plus 12 gives us 84 centimeters squared. Okay? It's not real big, but you have to know your area formulas for this to work. Alright, so this time they're telling us it's a hexagon, hexagonal prism, with a side of length 6, so that's S, because hexagons need the NAS, right? And N would be 6. And it says a prism height of 12. So picture you've got a hexagon and another hexagon, and everything is connected up and makes a prism. Okay? The height of the prism is 12. And then each of these sides is 6. So we need to add up all of these rectangles. And what do you know about all of these rectangles? Well, you know that all of the sides of the hexagon are the same. Therefore, all of the rectangles around the outside of the prism are the same. So we've got 6 rectangles that are 6 by 12. So 6 rectangles that are 72. This is your lateral area. All of the rectangles added up together. Plus 2 of the hexagons. Now hexagons are a little different story. We did these not very long ago. These are 1/2 AP, 1/2 NAS kind of problems. So you know the side is 6, so you know this is 3. We need to find A, so we can find the area of this hexagon. We know that when we find the angle in a hexagon, this is 30. Do 360 divided by 6 and then divide by 2, and that gives you 30. So it's a 30, 60, 90 triangle. That means that A has to be 3 root 3 because it's across from the 60. So this is 3 root 3. So to find the hexagon, we do 1/2 times N times A times S. So we get 3 times 3 root 3 times 6. We get 54 root 3. This is 1 hexagon. We need 2 of them. So we're going to put this into our formula, and then when we type it in, we're going to double it because we need 2 of them. So now our surface area, we're going to take 6 times 72 plus 2 times 54 root 3. We're going to get 619.1. And it's meters squared because that's the units on the hexagonal prism. Okay? Alright, so some formulas here. And this actually, it only works with a right prism. If it's oblique, it doesn't work. And this is actually, the formula down here is actually the one that I used before. It only works with the pH as your LA. This only works with regular polygons. With regular polygons. That means it will not work with a trapezoid or a triangle that's not equilateral. Those kind of prisms, that pH formula won't work. So then you're stuck making this the area of all the rectangles. Okay? So far, the only one that we've been able to use the P times H formula for would be the hexagonal prism. Otherwise, you have to find the area of all the rectangles and add them all together. 2 capital B is area of the bases. So for a prism, we add up all the rectangles plus 2 of the bases, and that gives us our surface area. Alright, another type of prism is a cylinder. Cylinders are just prisms that have bases that are circles. And it just so happens that the surface around the outside of a cylinder, like think of the label on a can of vegetables, is a rectangle. So they still have a rectangle as their lateral area, but then the bases are circles. The altitude is still the same, the height is still the same. So these are still related. They still tell you if it's straight up and down or if it's sideways, so you know the height. When we get to volume, that's going to be important. So, the net of a cylinder. This is the net of the cylinder. The lateral area is a rectangle, so if we folded this back up, we would have a can, like a soda can or a vegetable can or something like that. The lateral area is the rectangle that wraps around it. And then to find the surface area, we add the area of the rectangle plus the area of the two circles. And it just so happens, cylinders have formulas. They have a specific formula. You can do it a different way, but these have formulas. So this formula down here is the one that you want to pay close attention to. This is surface area of a cylinder. So when I ask you for a formula, you're going to write 2 pi RH plus 2 pi r squared. 2 pi, you've used that before. R is your radius. H is the height of the prism. Plus 2 pi r squared. Pi r squared is the area of a circle, and you have 2 of them. So that's why you add 2 pi r squareds. Alright, so let's go through and let's figure out what we know here. It says the radius of the base of a cylinder is 4, and its height is 6. And we're going to find the surface area of the cylinder in terms of pi. So we do surface area, 2 pi r h plus 2 pi r squared. I know, more formulas to learn, but it makes it so much easier. So now we just need to simplify. So if we do 2 pi times 4 times 6, we get 48 pi. And then 2 pi times 16 is 32 pi. So when we add those two together, we get 80 pi, and then it would be inches squared. Alright, same with this one. It says a height of 10, radius of 10. And we want to leave it in terms of pi. So surface area equals 2 pi radius height plus 2 pi radius squared. And do some math. 2 pi times 10 is 200 pi. 2 pi times 10 squared, also 200 pi. So this gives us 400 pi, and then it would be centimeters squared. Alright, next shape on the agenda is a pyramid. It's a polyhedron where one face can be any polygon. So the bottom of a pyramid can be a triangle all the way up to a million-gon if you want it to be. One face, which we call the base, it'll be the bottom of the pyramid most of the time, be any polygon. And then the other faces, which we call the lateral faces, these are all the faces around the top of the pyramid. They're all triangles and they all meet at a common vertex. A regular pyramid has a regular polygon base. Okay, so regular pyramid base is a regular polygon. And then the lateral faces just happen to be congruent isosceles triangles. Otherwise, any other pyramid, the triangles around the top are not congruent. So we have to pay attention to that. The slant height, which is a new thing, is the length of the altitude of a lateral face of a pyramid. So think the height of the triangles around the outside of the pyramid. And slant height is L, a cursive L, if you will. Okay, so they'll try to show this to you in italics or whatever, but it is a cursive L. Alright, lateral area for a pyramid is the sum of all of the congruent lateral faces. So if I highlight these in yellow, these are all lateral faces. So if you want to find the lateral area of a pyramid, you add up the area of all those triangles. The square here is called the base, and so we would add that in to do the surface area. Alright, formula. For a pyramid, you don't have two bases, you only have one. So surface area is the lateral plus the area of the base. The lateral area is 1/2 PL. P is the perimeter, so P is the perimeter. L is the slant height. That is an L, not a 1. Okay? So if you were going to do the lateral area of a regular pyramid, so that means it has to have a hexagon or a pentagon or something like that on the bottom, then you could do 1/2 PL. And then this is the surface area of a regular pyramid. Otherwise, if it's a pyramid with some obtuse triangle on the bottom, you would just add up all the surfaces, all the areas of the surfaces. All right? So this one, it tells you it's a hexagonal pyramid, which means it is a regular pyramid. So then we can do surface area equals 1/2 PL plus the area of the base. Okay? So 1/2. P is the perimeter of the base. So if one side is 6 and it has 6 sides, the perimeter is 36 inches. And then L is the slant height. Usually it's a different color. It's this 9 out here in red. So the slant height is 9. If you don't have the slant height, we'll have to find it. Alright, and then the base. We need the area of the hexagon. So that's 1/2 times N times A times S. And if you don't have any of those, you'll have to find them. That's part of the deal. Alright, so 1/2 times 6 is 3, times 3 is 9, times 6 is 54 root 3 for the hexagon on the bottom of the pyramid. So we would add 54 root 3 for this. Alright, so we're going to do 1/2 times 36 times 9 plus 54 square root 3. We get 255.5. And it's inches squared, because that's the units on our problem. Alright, this time it tells you it's a square pyramid, so it's still regular, it just has a square on the bottom of it. The base edges are 5, so the edges of the square are all 5. And the slant height is 3. So we do surface area equals 1/2 perimeter of the base, so the perimeter of the square would be 20, times the slant height, which is 3, plus the area of the base, and the area of the square is 25. So we do 1/2 of 60, which is 30, plus 25, we get 55 meters squared. Alright? A lot to take in. Okay, a type of pyramid is a cone. A cone is just a pyramid. It just doesn't have the triangles around the top of it. But it does have a circle for the base. A right cone just means it's standing straight up and down. The slant height is the distance from the vertex to a point on the circle, and we still call this L. It's actually slanted. Alright, the height of the cone is different. If they ask for the height of the cone, or they give you the height of the cone, that is here. Slant height and height are two different things. Okay, and that makes a difference when we get to volume. Alright, formulas, and I know I've got a lot of stuff going on here. Down here is the formula that you want to pay attention to. Surface area of a cone, pi r L plus pi r squared. Okay, pi times radius times slant height plus pi r squared. Pi r L is the area of the curved part around the top of the cone that's pointed at the top. Pi r squared is the area of the circle on the bottom. So you add those two together and that gives you your surface area. Alright, so for this cone, it tells you a radius of 15, slant height of 25. Alright, so surface area equals pi times r times L plus pi radius squared. Now you should be able to type this all in the calculator all at once. So we'll do pi times 15 times 25 plus pi times 15 squared. And we get 600 pi, and it tells us to leave it in terms of pi. If we needed to switch it, we could just hit the button and switch it. So 600 pi centimeters squared. The formula for a cylinder and for a cone, you're just going to have to know. Everything else, you can just find the area of all the surfaces. But the two that involve circles, you're going to have to remember the formula for. Alright, they want just the lateral area. Lateral area of a cone is pi RL. It says a radius of 15 and a height of 20. Now that makes a huge difference. So let's say we drew a cone. Never mind my art skills. This is the height. This out here is the slant height. What do they make with the radius? Makes a right triangle. So could we do Pythagorean theorem and find what we need to? We know R is 20, or R is 15, sorry, and H is 20. So we could do 15 squared plus 20 squared equals L squared. So let's do a little Pythagorean theorem math here and figure out what L is. Alright, according to Pythagorean theorem, L is 25. If you still don't know how to do that, we need to talk. So then if we're going to do LA, we do pi times the radius times the slant height that we just found. Alright, so pi times 15 times 25, we get 375 pi. And I'll just leave it in terms of pi because we can always switch that to a decimal real easy. Okay, gotta know your formula and you gotta know what they're giving you. And then you've got this under control. Okay? Alright, and that is it for section 11.2 and 11.3. You've got some new formulas to remember. Now I need you to go over to my website, take the lesson quiz, and see what you picked up from this lesson. Alright? See you in class.